do kind of keeps it attached.
Yeah, I've changed the way I'm doing things this year just to try and better prepare. Okay. So way back in grade 10, and we reviewed it last lesson. We talked about how to use right triangle trick. Find missing sides and missing angles in right triangles. Okay. Well, what happens if the triangles are not right triangles? Then we need a slightly different way to do them. But fortunately, we can use variations of sine and cosine functions to find. So I'm not going to go through the proof of how to use sine law to find missing sides and angles in certain non-right triangles, but just basically it looks like this. So remember in any triangle, so we're talking non-right triangle, we've got three angles that we normally label with capital letters, and we've got three sides that we normally label with lowercase letters. So sine law says the following: if we take one side over the sine of its angle opposite, it's going to equal another side over the sine of its angle opposite, which is also going to equal the sine of the third side over the sine of its angle opposite. And normally when we do these, we only pick two out of the three, and then use algebra to find the missing side or missing angle. So you'll see it look like this. Sometimes you'll see it flipped. So it'll say sine A over A equals sine B over B equals sine C over C. Means the same thing. You don't have to worry about this for your reference sheet because you are going to get this on your formula sheet. You will always get this. You do get quite a few formulas on the final exam, and this is one of them. Okay, so let's just use this to find some missing sides and missing angles in some non-right triangles. So here we have a triangle ABC. We're told the measure of angle A. We're told the measure of angle B. We're told the measure of side B, little b, which is opposite the 70-degree angle, or we could call it AC. We want to find little a. So basically what we want to do is we want to set up two fractions that equal each other, where we know three of the four pieces of information, and the fourth is what we're trying to find. Okay? So in this, we know one of the sides and its angle opposite. So I'm going to set up half the formula, 80 over sine of 70 equals, well, I want to find side A. I know its angle opposite is 60, so the second fraction is going to be A over sine 60. Those two fractions or proportions will equal each other. So once you've set up, then it's just algebra to solve. And when you have a single fraction on either side of the equation, you can get rid of both fractions at the same time by cross multiplying. So if I go like this, I can state that A times the sine of 70 degrees is going to equal 80 times the sine of 60 degrees. Because remember when we solve equations, if they've got fractions, we want to get rid of them right away. Okay. Well, we want to get A by itself. Right now it's got a times sine 70 with it, so we got to divide sine 70 to get rid of it. Which means I've got to do the exact same thing to the other side. And now I've got it set up to use my calculator. To find A, I'm going to do 80 times the sine of 60, and I'm going to divide that result by the sine of 70. So 80 times sine 60 gives me 69 point something, something, something. Divide that by sine 70. And let's just go one decimal place. A is approximately 73.7. Make sure that when you're doing it on your calculator, it's back in degrees. Because you guys, some of you guys have been using your calculator in radians. So make sure you're in the right mode. Otherwise, you're going to get a very different answer. Okay? No.
Did you know, like, multiply each side with some 60?
Yeah, basically that's what we're doing is we're multiplying both sides by sine 60. Then we're multiplying both sides by sine 70 to get rid of both fractions. And so when I do that twice, I actually end up with this. Yeah, so I'm just sort of saving a couple of steps, but you're right, that's how we get it. That's why we can cross multiply. Okay. This one, we're asked to solve the triangle. Remember, if you're asked to solve a triangle, that means you're asked to find all missing sides and all missing angles. So I need to find little a, little b, and angle b. Well, let's do angle b first, because we actually don't have to use trig to find angle b. How can we find angle b? 180 minus 80 minus 40. If we know two of the angles in a triangle, we find the third one by subtracting those two from 180. So we get 60 degrees. So we've got that taken care of. And now to find the missing sides, well, we know all the angles. We know one of the sides, so we can use sine law twice. Once to find A, once to find B. So to find little a, I'm going to use the known side over its sine of its known angle, 17.4 over sine 40. Is going to equal a, which I'm trying to find, over the sine of its opposite angle, which is 80 degrees. To find b, I'm going to use the same 17.4 over sine 40, the known side and known angle opposite, equals little b over the sine of its angle opposite, which we already found to be 60. So those are two equations to find a and b, little a and little b. So again, to get them, cross multiply each one. So we're going to get a times sine 40 degrees is equal to 17.4 times the sine 80 degrees. Divide both sides by sine 40 to get a by itself. And to find a, it's going to be 17.4 times the sine of 80 divided by the sine of 40. And we'll go to one decimal place. And I'm going to cheat a little bit because I've already got the answers. Should get 26.7. B, A, and now I'm going to cross multiply this equation. Get this. By both sides by 40 again to get B by itself. So this time on B, we're going to do 17.4 times the sine of 60 divided by this 40. And that's going to give us approximately 23.4. So how do we know when we can use sine law? We can use sine law. Let me highlight. I have to do it this way. Whoa. Okay, stop doing that. All right. We can use sine law. In this situation. As long as we know an angle and its opposite side, I can use sine law. Okay, that's on the front page. So think of that when we answer the questions in the next exam. Remember, if you know a side and an angle opposite that side, you can use sine law. So for A, well, I know a side and an angle opposite. So, yes, I can use sine law in this one. This next one is a little tricky. Because first of all, it's a right triangle, so one would assume that we would use right triangle trig. But technically, you could use sine law. Because you do know a side and its angle opposite. It just happens to be 90 degrees. So we do know a side and its angle opposite. So like I said, technically we can use sine law, but most of the time we would look at this and say, oh, well, it's a right triangle, so we use right triangle trig. So yes. How about C? No. I've got one angle, I don't know its opposite side. And if I only know one angle, I can't find the other ones. I gotta know two angles to find them. At least I gotta know at least two angles to find the third one. So no. Which means we need another law, which we'll talk about next week. That's actually a cosine law one. Okay. Now this one you gotta be a little bit careful. Because on initial inspection, you would say, okay, I know this side, but I don't know its angle opposite. But can you find this? Yes, it's actually 80 degrees. So if you know two side angles, you can fill in the third angle, and that allows us to use sine law. Okay, what about finding a missing angle? And that's the next example. So we've got another non-right triangle ABC. We're given one of the angles. We're given two of the sides, and we're asked to find the two missing angles. Well, notice you know a side and its angle opposite. That means I can use sine law in this case. But this time what we're going to have to do is, okay, we know this, so we're going to use this in one fraction. Let's find A first, so we're going to use this in the other fraction. So little 8
over sine 58 degrees is going to equal the fraction 7 over the sine of its angle opposite, which is angle A, which is one of the angles we're trying to find. And now we're going to algebra. So cross multiply to get rid of the fractions. And I get 8 times the sine of A equals 7 times the sine of 58 degrees. Well, let's get rid of the A, or 8 first, because that's actually furthest away from A. The sign is right beside it. Remember, this is connected by multiplication, so to get rid of it, I have to do division. So once I do that, I'm going to have sine A by itself is equal to sine 58 degrees divided 8. Remember, this is not sine times A. So don't divide sine. You can't do that. Okay? How do you get rid of just sine? Sine inverse. Oops. Nope. Remember, when you're finding the missing angle in these cases, the last step is always going to be inverse. Whether you're using right triangle trig, whether you're using sine law, whether you're using cosine. So make sure you're comfortable with doing this on your calculator, because it is kind of stuff. What I do is, like using my calculator, I get this answer first and then take the sine inverse of it at the end. You don't have to. You can do it in another order if you want. But if I do 7 times sine 58, get that answer. Divide 8, get that answer, and I'm going to get 0.742 and some more digits. Then on my calculator, I can just do second sine for sine inverse, and then second negative sine of the previous answer. And it gives me 47.9 degrees. That's what you should get. Make sure you know how to do that on your calculator. And of course, to finish up this question, we have to find angle C. I've already got A. Well, now that we know 2 of the angles, it's 180 minus the one we just found, minus 58. So angle C will become, what do we get? Oh, I didn't find angle C in my, I have to correct that. 5 minus 58, 74.5 degrees. Okay, a couple of sort of word problems, but you get a diagram, which is nice. And actually, this is in one of my examples in grade 11 pre-calculus. We've got an airplane that's flying into a storm, so it's going to go around it. So it's taking its flight path, and then it veers off until it reaches sort of the peak of the storm to the left, and then it comes back to its original flight line. And we want to see
how much further we had to go. So basically, to find out how much further we have to go, we have to figure out what X and Y are, add them together, and subtract away what the distance would have been. Now, right now, looking at this, I don't know a side and its angle opposite. But can I find the third angle? Yes. I can find the third angle by doing 180 minus 21 minus 35. And I get 124 degrees. So we need to set up an equation to find X, set up an equation to find Y. So X first, well, I know this angle and its side opposite. So I can say that 70 over the sine of 124 degrees will equal X over the sine of its angle opposite, which is 21 degrees. And then I can go from there. I want you to finish it. Set up the equation to find Y, and then find X and Y, and then find the answer to the question we were asked. Okay. So, cross multiply X times sine 124 degrees. Let's equal 70 times 1 degrees. Divide both sides by 24. Get X by itself. That all in decimal place, and we get 30.3. 30.3 kilometers. Just to remind us of units this time. And then same first fraction, 70 over sine 124 degrees. This time it's going to equal Y over the sine of its angle opposite 35 degrees. Cross multiply, get rid of the fractions. Y times the sine of 124 degrees is equal to 70 times the sine of 35 degrees. Divide both sides by 24 to get Y by itself. That into your calculator, and Y would be approximately 48.4 kilometers. Remember, we still have to answer the question we were asked. So to find how much further the plane had to go, we have to find the total distance of the detour, and then subtract the original distance it would have taken, which gives us a final answer of 7.87. Sorry, no. I think it's 7.87. All right. I'll get 2 decimal places. Yeah, 8.7. I think it's 7. There's a mistake in there. Okay, last example. Again, a word problem. It's pretty safe to say on the provincial exam for this course that you're going to get 1 sine law and 1 cosine question. Of all the ones I've looked at, I've always seen 1 of each.
And it's either in just sort of a regular question, like the first few examples we did, or a problem. But with the problem, you'll get a diagram. See, like, where does this come from? Okay, delete. Oh, wait. Okay. Two observers on boats at A and B have located a sunken ship using sonar equipment. The sunken ship is in a line between the two observers. The angle of depression, if you remember way back from grade 10, angle of depression is an angle formed between an imaginary horizontal line and you looking down at something, or something looking down at something. So 40 and 36 on the diagram are angles of depression. Okay. The distance between the two boats on the water is 450 meters. How far is the ship below the surface of the water? So we want to find the depth. And we're asked to run to the nearest meter. So somehow we need to find, this is our ultimate goal, depth, which I'll just call it D. Well, notice the whole situation forms a non-right triangle. But if I draw in the depth, I create two right triangles. So if I look at one of the two right triangles, if I can figure out one of the sides in this one, or one of the sides in this one, I can use right triangle trait to find D. So it probably makes sense to find this here. Okay? Or this. And how can I do that? Well, looking at the big one, this is going to be 180 minus 40 minus 36. Which gives us 140 degrees. So I can use the big right triangle, and I'll just do it in a different color. So I know that this is 104. I know it's angle opposite. I know these two angles. Or sorry, I know it's opposite. I know these two angles, so I could use sine law to find this or this. It doesn't matter which one. We only need one of them. So let's find this one. And we'll call it, I mean, you can call it A, capital S. I'm just going to call it X. So looking at the big one, I've got 450 over the sine of its angle opposite, 104. Will equal the missing side X I'm trying to find over the sine of its angle opposite, which is 36. And then I can go ahead and use algebra to find that. So cross multiply and then divide both sides twice. So I get X times sine of 4 degrees equals 450 times sine of 36 degrees. Divide both sides by sine of 104. And that's going to give me my X. And it says nearest meter, so I'm going to go to nearest meter this time. And when I go to nearest meter, 273. So I get X is approximately 273 meters. So now if we focus on that right triangle on the left, we know that's 90. This is what we're trying to find. We just found this as 273 meters. And we know that this is 40 degrees.
Okay. Technically, you could use sine law again. Because it would be set up like 273 over sine 90 equals d over sine 40. That'll work. Okay? Or we just use right triangle trig.
If this is the acute angle, this is the opposite side, this is the hypotenuse, which tells me I have to use sine 40 degrees is equal to the opposite side 40d over the hypotenuse length, which is 273.
Yeah.
But we don't know this.
And we don't know that it's half of 450. Good question. Very good question.
Yeah. Don't assume that these two are equal, that you can split them in half.
We are not told that at all.
And actually, the only way you could do that is if these two angles were the same measure. Then you could split this in half.
If they're different, you can't split it in half.
Yeah, no, I'm glad you brought that up. So multiply both sides by 273.
And that's going to give us our missing
depth,
which for one decimal place, when we use right triangle trig, 175. All right.
That's our final answer.
But again, you could have used, like I said, it's possible to use sine law in a right triangle. Okay.
That